Welcome to Section 5, Advanced Analytics. And if you're coming from Section 4, that's perfect because we'll be building directly upon the real-time and historical tick architecture that we just created. Now, if you're coming in fresh, that's all right, but what you'll do is go through this entire notebook, which is Section 4 and 5. You'll have to run all the cells in Section 4 just to create that real-time and historical tick architecture. And then in this section, we'll be building upon that architecture with a few more complex analytics. The first benchmark we'll be calculating is VWAP, and VWAP is the volume weighted average price. Now this is a benchmark that's used throughout the financial industry, and basically you can think about it as giving more weight to prices where more trades have occurred. And this in turn gives a more representative look at the average price levels. So within the financial industry, it can be used for things like benchmarking trades, where we can gauge the quality of our trade executions. Algorithmic trading, where many algorithms use VWAP to ensure that execution of large trade orders does not impact the overall market significantly. And finally, performance measurement to help traders measure the efficiency of their trade. VWAP is calculated by taking the sum of the price multiplied by the volume divided by the sum of the volume. So to calculate VWAP, we'll take a function and call it RTE VWAP, where we'll pass it a symbol of interest. Our goal is to create this function and then add it as an API to our real-time processor, which is getting real-time data from our chained ticker plant. Now, how we'll implement this is using a select statement upon our trade table, and we'll do the calculation to find what the VWAP is at a minutely cadence. We'll calculate this by taking the price column, multiplying it by the volume column, and then taking the sum of that, and then dividing that by the sum of the volume column. And we'll rename that to the VWAP column. We need to ensure also that we're only doing this calculation on rows that include the symbol of interest that we're passing in, and we will group by minutely sections. Then we'll return that VWAP. So if we run this, we'll register it as an API. So we're just taking this function and registering it as an API on our real-time engine that we just created in Section 4. And then let's go and test this out. So we can see that data has been running through this for about 30 minutes now, and we can see at each minute the VWAP. So we were successfully able to create quite a complex analytic on the real-time data coming through the real-time processor. Now that we've created that API, we can add it to the gateway. So we'll create a gateway VWAP function that goes ahead and calls that VWAP API here. And we'll have to just restart the gateway because we're going to be adding that new gateway VWAP function to it. We'll restart our gateway, giving it access to PyKX, giving it access to the original gateway function we created in Section 4, as well as the new gateway VWAP function that we just generated. We'll give it connections to the HDB and the RTE, and use our user validation function for some basic authentication. Now we can go ahead and test out our gateway and see if we can access the gateway VWAP API. And we were successfully able to find the VWAP for all of the minutes that are streaming through our real-time processor. Next, we will find the volatility, which is a statistical measure that tells us how much and how quickly the price of an asset is moving. Now, volatility is widely used in the financial markets for a variety of different use cases, including risk assessment. And you can think about it as with more volatility, your prices could change more drastically in a short amount of time. So that might mean a more risky asset. Pricing derivatives. Volatility is also a key input in pricing out options and other types of derivatives, as well as portfolio management. Helps investors to diversify their portfolios by understanding which assets might be more volatile than others and weight the riskiness of their entire portfolio. So to calculate the volatility, there are 5 key steps that we have to follow. First, we'll combine the bid and ask prices to get a representative price. Then we'll calculate the percentage change using logarithms between those consecutive prices, square those changes, making them all positive, and importantly, to emphasize the big changes, smooth out those changes using exponential moving average, and finally take the square root of the smoothed value to get the volatility. So this is a relatively complex calculation that we're doing that contains many different steps. And while Q, which is the underlying programming language for KDB Plus, is not in the scope for this course, we're going to show how you can use Q to calculate this in a single line of code. And if you're interested in learning more about it, we have several courses in the KX Academy that will teach you the basics of Q and KDB Plus if you're interested in squeezing the absolute most optimization within your queries. So what we'll do is create a function called getVolatility, do the imports that we need, and then we define this Q function to calculate the volatility for us. And you can see we call it getVolatility, and then we have some Q code here that walks through all those 5 steps and does it in one line. Really handy. After we define that function, we'll get the data that we need using a PyKX select statement here on the quotes table. We're interested in, of course, only the symbol that we're passing into the function, and then the time span between the opening and the closing of the market each day. We'll then group by minutes using minute.xbar and reset the index. So to calculate the volatility, what we'll do is take that KDB plus Q function that we just defined above and then pass it the subset quotes, bids, and asks that we just calculated here. We'll then do some date-time formatting and return the results as a dictionary. So that is the function we'll use to calculate our volatility, and we can test it out and see we can find our volatility over every single minute within the time span that we defined for, in this case, Google. So your final exercise for this course will be to register this API that we just created to the HTTP and call it volatility_HTTP. Now, once you've coded that out, you can test it by running this block of code, which will show if we're able to access that volatility HTTP API that you just created. Lastly, after you're complete with the notebook, go ahead and run these cells to shut down our live data feed and the entire tick architecture. And that will conclude our course. So I just want to say thank you for joining and walking through this course with me. I've really enjoyed it, and I hope you have learned some things about PyKX and working with live data and historical data and the ability to build up an entire real-time and historical tick architecture. Next, you can take the exam at the end of this course, and once you pass that exam, you'll get a certificate of completion. Thanks again, and we'll see you next time.